Okay, here is why you have to go the opposite direction whenever it is in the parentheses. Now you'll notice I have a completely new board here with a new question. This is not the parent function anymore. And look how the way they wrote this. They wrote, the instructions in the book will probably say, using the letter F, graph these two, describe the transformation from the graph f of x to the graph h of x. They'll probably say something like that. And so they're going to ask you probably in our questions to graph both of these. Now this one should be a quick one to graph. If you want to make an X and Y table because you're not that confident with your own mental math skills, you can, right? You could put 1 up in here and work it out. You could put 2 in here and work it out. You could put 3 up in here and work it out, right? It wouldn't be hard. 3 times 1 is 3. 3 plus 1 is 4. If you put 2 up there, 3 times 2 is 6. 6 plus 1. If I put 3 up there, 3 times 3 is 9. 9 plus 1 is 10, right? You could graph all those points. Obviously, this graph over here doesn't go to 10, but you could. But if you've been paying attention to the slope and intercept stuff in this lesson, you would know this is the y-intercept. And so I'm going to start my graph at positive 1, right? And then the slope is right here. The slope is the 3. And so the 3 is going to be up 3 over 1. Up 3, 1, 2, 3, over 1. Up 3 over 1. So I have my graph. There's the first one. I would probably want to label this back in the day. This is f of x. I could write the whole thing, but I'm just going to put f of x. All right, and you'll see that this point, 1, 4, is actually right here that I graphed, and 2, 7 is actually here. So I ended up graphing some of those points. Now, how is it different whenever you have this? I'll do this one in purple. F of x, f parentheses x minus 2. I just got done telling you. Okay, sorry about that. This is where the x is in the parentheses and the minus 2 is in the parentheses. So this is a horizontal translation, and this is actually going to move 2 to the minus 2 makes you think it would be 2 to the left, but remember, these horizontal ones are opposite. This is actually 2 to the right. Now, if I was in a hurry, could I just take all 3 of these dots that I made and just scoot them over 2 places to the right, and would I be correct? Yes. In fact, that's what I would normally do in a typical situation. But since this is the first time, I want to really prove to you, why does this go to the right? Just because Mr. Reed said so? No, you shouldn't believe me. Let me show you why that's actually the right answer. So if I was making my little input-output table on this one, I would say, okay, I've got my x, and here I'm going to do the h of x, kind of weird thing here. Okay, normally I would pick easy numbers like 1, 2, and 3, right? Normally I would do that. But look what happens. When I go to put 1 into this problem, it's 1 minus 2. And it's not like it's the answer. It's not the output. 1 minus 2 is in here with the parentheses. So 1 minus 2 is actually telling me, even though I picked the number 1 to plug into the problem, over here, I'm actually going to end up picking negative 1, right? Because I'm going to take 2 away from it. When I take 2 up in here, instead of plugging in 2, I actually need to plug in 2 minus 2. I actually need to plug in the number 0. And then here, the number 3, when I plug 3 in here, 3 minus 2 is actually 1. Sorry, that's kind of right on my purple line there. So instead of plugging in the numbers 1, 2, and 3 into this equation like we did with the orange guy, I'm actually going to end up plugging in these completely different numbers. I have to take the number that I wanted to use and subtract 2 from it. I had to take all these numbers that I wanted to pick, take away 2 from it, and then I'm going to plug in these numbers. I'm going to put negative 1 right here. 3 times negative 1 is negative 3. Negative 3 plus 1 is 2. Negative 2. If I wanted to plug in 2, but the process of this made me actually put in the number 0. If I put 0 right up in here, 3 times 0 is 0. 0 plus 1 is 1. And then if I take the number 1, I wanted to use the number 3, but this told me I had to take away 2 from it, so I actually end up plugging in the number 1. 3 times 1 is 3. 3 plus 1 is 4. And so whenever I graph these, when I graph it, I have to use the number that I thought I was going to pick, right? These manipulated numbers don't actually play a part. I'm actually going to use these original numbers that I wanted to pick. I wanted to pick the number 1, and then I ended up with a strange answer of negative 2. 1, negative 2 down here. I wanted to pick the number 2. I ended up with the answer of 1. And I wanted to pick the number 3, and I ended up with the answer of 4. 3, 1, 2, 3, 4. And so you can see if I make this line straight, I don't have a ruler, but if I do my best, you can see what ended up happening to this graph was that this dot and this dot are two spaces. See my spaces right here? 2 spaces away. 2 spaces away. I could put another dot up here even though I didn't. 2 spaces away on my graph. Down here I had this point that I graphed on the purple one, but I didn't graph it on the orange one. It would have been right here, right? 1, 2 spaces away. And so that's why it actually is the opposite of what you think. So that is that one. So this was a horizontal translation, 2 to the right. How much time do I have on this? I'm only at 4 minutes. Let me do some other ones. Let's do this one, and then we'll call this one good. Now this one is different, right? You notice, wait a second, doesn't this look familiar? This is the same thing, right? F of x equals 3x plus 1. That's the graph we just did. On the other one, so the y-intercept, remember that was the letter B. The y-intercept right here is 1. I'm going to put a dot on 1. The slope, I don't really need to make an x and y table for this. The slope is 3, so from this dot, I'm going to go up 3 over 1. I can do it one more time. I actually don't have space to go up 3, so I'll kind of freehand it. So this is the first one. This is our f of x graph. And now this guy is similar to the last one. Look at the last one. The last one had x minus 2 in parentheses. And so we said that was 2 to the right, the opposite of the way that it looks. This one is not in parentheses. It's just the G answer here, our graph of letter G, is going to be whatever f of x is minus 2. The minus 2 is not in parentheses. Remember, excuse me, when it's not in the parentheses, it's like these over here on the left. It's just a vertical translation up or down, and it's not going to trick you. So this is just a normal one. This is a vertical translation. And this is going to be not tricky. And the minus 2 is going to be down 2 units. We should have just shifted everything down 2 units. Now, can I prove that to you and make sure that it's right? Yeah, I can do that. I'm going to take my new equation right here, x and g of x. I'm going to pick whatever numbers I want. Let's pick the easiest numbers we can think of, 1, 2, and 3. And look, when I plug number 1 into this, I don't have any weird stuff that's going on. When I put number 1 right here, it just says, okay, do f of x, which is this guy, whatever your answer is, and then take 2 away. Okay. So if I put the number 1 in here, I would get 3 times 1, that's 3. 3 plus 2. Wow, let me try that again. If I put the number 1 in there, I'd get 3 times 1, that's 3. 3 plus 1 is 4. Normally I would say 4, but look, this has the minus 2 at the end. So it's not just 4, it's 4 minus 2, that is 2. On this one, when I put 2 up in here, it says do the problem like normal with 2, and then just take your answer and take 2 away from it. So if I did the problem like normal, I would have this. 3 times 2, that's 6. 6 plus 1 is 7. My normal answer would be 7, but it says minus 2, so I'm just going to move it down to 5. And then here, if I took 3 and I plugged it in, it says do the normal question with 3 and then just subtract 2 from it. So if I put 3 right here, 3 times 3 is 9, minus 1, that is 8. 9 minus 1 is 8. And then it's almost like you have this extra braces and it says, okay, no, 8, now you got to do minus 2. So I'm just going to take 8 minus 2 and get 6. And so if I graph these 3 points, I should get 1, 2, 2, 5, and 3, 6, which is like right here. I should have this thing that's been shifted down 2 units. Now, it's kind of hard to tell that it's shifted down 2 units because I'm not a great graphing person, but you can kind of see this one touches the y-axis at -1. See how this dot compared to this dot is down 2 places, right? Between here and here, you have 2 spaces on the graph. Same thing between there and there. You have 1, 2 spaces on the graph. And so this is a vertical translation down 2 units. Okay, I'm going to stop right there, guys. This is a whole lot to watch. Have a good one. I'm going to try to put some questions out there eventually, and I will see how we do. See ya.